world of watchmaking is full of complications. Some complications might be more useful than other complications. Take for instance a moon phase or an equation of time or a tourbillon, although a tourbillon is not officially a complication. One of the proper useful complications is an altimeter, and in 2017 Favre-Leuba introduced the Bivouac 9000, a wristwatch with a built-in altimeter. Next time you want to go skiing or hiking in the mountains, take a Bivouac with you and it will tell you exactly at which height you are, how much you've ascended or descended, and it gives proper practical information about how you're traveling in the mountains. We're talking with Thomas Morf, CEO of Favre-Leuba, about the Bivouac 9000.
Favre-Leuba is definitely one of the most legendary brands in Switzerland. Was founded in 1737 by Abraham Favre. It left behind a legacy of interesting watches, highlighting in the Bivouac in 1962, also with the Bart in 1968, first altimeter watch, first depth gauge watch for people conquering frontiers, which is still the claim today, which we are also communicating heavily. But it's not only for that, it's not only for professionals, it can be worn by people who like to challenge themselves in their everyday life. And it was important to bring these two models back again, but not just a copy-paste version. Instead of we set our bars even higher, we came up with the Bivouac that allows to go up to 9,000 meters above the Mount Everest.
My name is Nicolas Hoyak. I'm a Swiss mountaineer. I'm specialized in expedition and speed mountaineering. I like to climb up and fly down with a paraglider and make like that some link-ups. In 2015 I climbed together with Uli Steck the famous Eigen North Face in 3 hours and 43 minutes, and like that we did the fastest team ascent in history. The watch is really an eye-catcher. A lot of people ask me, people are looking, what kind of watch? And then, a lot of asking. Yeah, on an expedition, it's also really helpful to know the altitude when you are on such a big mountain like the K7. So you know really the altitude and you know the distance to go up to the summit. So it's really useful.
We have once the hour and the minute hand, as in a regular watch, and we also have a small second at 9 o'clock. What also belongs to the basic movement is the power reserve indication up at 12 o'clock. And then the red hands, these are the hands for the altimeter function. If the red hand, the center hand makes 360 degrees, then you have a difference in altitude of 3,000 meters. The center hand makes basically 3 turns maximum, and then you're at 9,000 meters. On the small subdial you can see if you are between sea level and 3,000 meters, between 3,000 and 6,000, and between 6,000 and 9,000 meters. And just across this indication we have also the hectopascal. It shows you the actual air pressure.
So many people used in the 60s and the 70s, they used the Bivouac to conquer new heights. For instance, in 1975 there was the first woman on the Mount Everest. It was a Japanese lady. She used a Bivouac as well. Not only because of showing the altitude, because it only went up to 4,500 meters, but being a barometric device, also indicating you the weather forecast. And this is key. If you ascend at the wrong weather, if you take the wrong decisions, this could be fatal in your endeavor to go to a summit of a mountain.
That means also if you stay on a certain level, like for example here where we have our offices, this is at 400 meters, but the air pressure changes. It depends if it's cold weather, warm weather, if it's cloudy or sunny, if we have more humidity or less humidity, the air pressure always changes. That means the hands will not stay always at 400 meters here. Then I have first to adjust the watch. Therefore, I have a bezel here, or this bezel here, which is around the watch. And you can move this bezel on the left and on the right side, to the right side. So it's bi-directional. This office here is at 400 meters, and so when I take my watch, I adjust this bezel exactly that across my hand here, my red hand here, is the 4 for 400 meters. And then I have adjusted the watch and I can start walking. And then it will show me all the time the right altitude. And this function, because it's an aneroid barometer, people who go often in the mountains, people who do expeditions, they like these aneroid barometers because it measures the air pressure, and the air pressure is important to know how the weather changes.
When you get up early in the morning in the hut and you can look on your watch and you see the barometer has changed, you know the weather is also changing, so it's perhaps not the best day to go on a really big trip, so you can decide if you go back to the valley or you stay in a hut like that. Before I had the Bivouac 9000, I had this electronic altimeter, and the problem is when you are up there and the battery is low, you have really big problems sometimes. So this is really mechanical, so I can trust it every time, and the function is given, so I have no problem.
We said these two legendary models, the Bivouac and the Bati, which came in 1968, in order to make an impression that lasts again for the brand, we said, why don't we develop a new Bivouac and Bati, but I'm talking about the Bivouac now. But it cannot be just an ordinary watch, just copy-paste, the same principles. We said we have to go beyond. And beyond means we have to push boundaries for ourselves. And that's one of the reasons why we develop everything in-house with very talented engineers. And we said it was clearly that we wanted to go to the next level, not only showing the barometric pressure and showing the weather, but it has to go up to where the roof of the world is, and this is the Mount Everest. So we started to develop the Bivouac from two sides. On the one hand side, we were using design elements that are typical Favre-Leuba. And on the other side, we were developing things from a technical side. The technical aspect was a new challenge. We had to develop everything from scratch. Of course, the barometric pressure capsule is more or less the same, but to go up to a 9,000 meter is a big difference. It's an exponential challenge to that capsule to really work on all altitudes. Also, we wanted to use a central hand for indicating the altimeter. Also, that's the reason why we have a hand-wound movement, that the altimeter hands is going through the movement. It cannot be solved with a automatic base movement. So we deeply modified the movement as well. We have a base caliber which we use, which is from EMC. And then the entire capsule was developed.
As soon as you get up, then you have less air pressure and air pressure, and the capsule can expand. And when the capsule expands, you have a lever here. That lever starts moving up. It is very small. We're talking about a few tenths of millimeters, but it starts moving up and it transfers its movement to a gear train. And the gear train transfers its movement to the hands. Here you can see the capsule. This is a cut through the capsule. Then you see how it looks like. This special shape has to be because it's a linear indication. That means the hand makes the same distance, the same number of degrees, the center hand and also the hand at 9 o'clock on the subdial, if you go from 0 to 1,000 meters or if you go from 8,000 to 9,000 meters. The more the capsule expands, the more tension we also have on the material. And we have to compensate that so that we always have the same distance, no matter if we go from 0 to 1,000, from 3,000 to 4,000 or from 8,000 to 9,000 meters. And we only achieve this regular or this exactly same distance or number of degrees from the hand with the shape of the capsule. And that was also one of the secrets of this whole development. So here you see the two levers. You see the capsule. Then we have here two levers. This is basically the same lever, but that shows you how the lever moves upwards as soon as the capsule expands. And the capsule expands when you go up the mountain. And it makes moving your whole gear train. So and here you see the gears, the indications, and it finally ends up here on the hands and showing you the right altitude. Important to know is also this is an aneroid barometer. That means we basically measure always the air pressure and we transform the air pressure into an altitude, into meters.
All the watches we have manufactured so far, we had no problems at all. There was some fine-tuning, it's an adjustment, what is required, and the result is an extraordinary watch which is one of a kind in the industry of the watch world. So the Bivouac 9000, we can really say is one of our highlight products, and the next highlight is ready and in the pipeline to be launched soon.